Today, I want to introduce you to optimization, and I have a pretty easy problem for us to do. So here's our problem. A farmer wants to create a rectangular pen for his cows. He has 300 feet of fencing. What dimensions maximize the area? Okay, so our first step is we're going to make a drawing. So we know we're going to have a rectangular pen, right? Something like this, right? And here we'll have width, and here we'll have length, okay? And what do we know about what we're trying to find? Well, we're trying to maximize the area. So we know area equals width times length. And what else do we know? Well, we know the perimeter, right? The total perimeter will equal 300, right? And what is the formula for perimeter? Well, it's 2 times width plus 2 times length equals the perimeter. So that'll equal 300, right? And here we have our optimization equation, and here we have our constraint equation, okay? Now, what are we going to do? Well, we want to find the maximum for this area, but we have it in terms of 2 variables, right? But we only know how to work with 1 variable, right? At least for now. So what we're going to do is we're going to take this equation down here, and we're going to solve for one of the variables. So let's just say, let's solve for length. So 2 length equals 300 minus 2 width, right? And then length equals 100, 150 minus width. Now we're going to take this and we're going to plug it into there. So now we have area as a function of width equals, well, this will become width times 150 minus width. So now we can also say this equals 150 times w minus w squared, right? Then from here, we're going to take the derivative of this, and we're going to set that equal to 0, because we're trying to find a local, not minimum, but maximum, right? Because we're trying to maximize the area. That's very important for us to take note of. We're not looking for a minimum. We want to find a maximum. So we get the derivative of a of w equals 150 minus minus 2w, which equals 0. We find w equals 75. So now we think we know which width will maximize the area, but we can't be certain yet. What we should do is we should test it, right? Let's make that little diagram thing like we've made before. And down here we'll put 75, and let's test. When values are greater than 75, is this negative or positive? It's negative. And when values are less than 75, is this negative or positive? It's positive. So this is in fact a local max, right? Then from here, now we know our local max, which we'll say it's w. So w equals 75. Now we're going to take 75, and here we have our equation for length, 150 minus w. 150 minus 75, that's 75. So length also equals 75. And that right there are our dimensions that will maximize the area of the pen. Thank you for watching. Let me know if I say anything wrong, if you have anything additional to add. Have a great day.